Welcome back to our Inventor Nastran demo series. In this video, we will import our prepared model into Nastran and set up our finite element model with assigning, loading, and boundary conditions and preparing the mesh. If you're new here, make sure to subscribe and check out our first video from this series. Okay, so let's get into Nastran. So now we have the model that we prepared in the first video. So the next step will be to go into the Nastran environment. So let's go into the tab environments and click on Autodesk Inventor Nastran. Okay, so this is the Nastran environment with the ribbon, the graphics window, and the browser. So the first step in our workflow, it is define the idealizations. In the idealizations, we will be defining the type of elements and assigning materials. So let's go into solids, new, and the idealization dialog box has been defined. So we will be selecting the type of materials. There are different type of materials available in Inventor, which are the solid elements, shell elements, and line elements. For this case, we will use solid elements. And then the definition of the material is going to be done from here. So we will do a click on new material. And now we can see that the material dialog box has been opened. We click in select material and we will see this dialog box which opens the material libraries. Okay, so for this case we are going to select the steel mal. Steel mal will be our material. We click in here. We also could input, if they are available, the material properties on these boxes. So let's click OK. The material has been assigned, and now we are going to assign the geometry. So let's select here, and the geometry has been assigned to this idealization, and we click OK. Okay, so now we have a message that says that we have two idealizations in here. One of them is going to be removed. So let's click OK again, and the idealization that we defined is the one that is current. Okay, so for our simulation, we're going to prepare a static analysis or a cantilever beam. Okay, so that will require that we fix one end and apply the load in the other end where we prepare our location. So let's start applying some constraints. So let's go into constraints, right click, new. The constraint dialog box is open. So we click in here and select entities. Yes. And we have the possibility to adjust the translations and rotations to suit the specific boundary condition that we require. For this case, is fixed, and that has been defined, but there are other possibilities: fixed, no constraint, free, and rotation. We will see how to use them in future videos. In here, we can present a preview of the application of the load. Yes, we can see on these display options that we can have those symbols to represent boundary conditions. This is only for visualization, and it doesn't affect the result itself. Okay, so we just do OK. So our next step is applying the load. So let's go into load, click new. So the load dialog box has opened. We click in select entities to define the area where we want to apply the load. Let's do click in here in preview, density, and let's define the magnitude of our load. So the magnitude of our load is going to be 1000 newtons. Okay, 1000 newtons has been defined. And now we can see how the load has been applied. Okay, so clicking here. So our next step is the mesh preparation. Okay, so let's go into the node mesh model, right click and edit. So we're gonna work with an element size of 50. Element order is gonna be linear, and in the settings we will change these two settings from here. Yes, so the mid-size nodes. So we check this box and keep the mid-size nodes on, and the element growth we're gonna keep it in 1.1. With these two settings, with the mid-size nodes, we will allow for curved elements to be shown on this area when there is the right element size, and that will give us a more realistic representation of the mesh. And with this setting from here, we will have a way to control the transition between coarse elements and fine elements. So if we want to have a smooth transition, we will need to reduce this value. By default is 1.5. Let's remove it to, let's change it to 1.1. Let's clicking here. Let's do generate mesh. Okay, and now the overall mesh is a coarse mesh, but we will need to review the mesh in these areas. As you can see, there is no an allowance for curved elements in here because of the size of the mesh is too large. So we need to apply some refinement in that area to have a more realistic mesh. So let's do OK. Let's go into mesh model, right click, add mesh control. Yes, and this is the dialog box to add the different mesh control. You can add from a vertex, edge, part, or face. We're gonna use face, and we're gonna change this value to 5 millimeters, and we will be selecting the radius faces. Yep, so that has been selected. And let's click in here, generate mesh. Okay, so now we can see that the mesh has been defined. Okay, so with our finite element model prepared, we are ready to run the simulation. So stay tuned for our next video where we will run in the simulation and analyze the results. Don't forget to like and share. See you soon.